Welcome to the Real Python Podcast. This is episode 167. What are the new ways to describe your data in pandas 2.0? Will the addition of Apache Arrow to the data backend foster the growth of data interoperability? This week on the show, we talk with pandas core developer Marc Garcia about the release of pandas 2.0. Marc shares his background and work on pandas. We discuss the history of data representation in pandas and the need to move beyond NumPy. We also talk about how Apache Arrow only solves some of the issues. We dig into the potential of an Arrow backend and how it could offer interoperability between data platforms. We also cover the many impediments of adoption and backward compatibility. Marc also shares his thoughts on making pandas more extensible. Marc was traveling when we recorded this episode, so please excuse the audio quality. I've done my best to try to clean it up for you. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hi, Marc. Welcome to the show.
Yeah, thank you.
It's exciting to talk to you. We've been kind of going back and forth for a few months here trying to get you on the show. My friend Garna, he's kind of introduced us, and I'm glad that he's done that. You had written an article back in, I think, February talking about pandas 2.0 and the Arrow revolution, and I really wanted to talk about that mostly, talk about Arrow and how pandas 2.0 is sort of implementing it. But maybe we could start with a little bit of background. How did you get involved with the pandas project in the first place?
Yeah, after being in the open source community for several years and Python, at some point I decided to move into data. I was into websites and Django in particular for a few years. Yeah, when I moved into the data space, like pandas is the thing that I was using the most. And at some point I found a few things that I didn't like. And at that time, one of them was like the documentation was like finding hard to learn pandas. I think the API is not very intuitive, was not then, and it didn't change much. So yeah, I found that examples would benefit the project a lot. So I started to work on some examples for the documentation. And the API is huge, like only series have more than 200 methods. So I started to get involved with other people, trying to encourage people to also contribute to that with a huge effort. I think it's been successful. I think like the documentation now, particularly the API documentation on examples, is doing pretty well. And then I started to work in other areas, eventually was promoted to the core development of the team. And here I am still contributing to pandas.
Yeah, it's great. So what time frame would that have been?
I think I've been at least 5 years. I'm not sure exactly, but yeah, something 5-6 years, I would say.
Yeah, the whole pandemic thing has screwed up everybody's relationship with time.
Yeah, maybe even 7. Yeah, now they just say like, yeah, I think like, the pandemic was 3 years ago and it was much before that. So yeah, I'm not sure. It's been a while.
I went through your website and I found a video that was you giving a talk at, I think it's called SciPy Latam. It was in 2019, and it was, I think the title of it was sort of the pandas of the future. And I want to use that as a reference point because I found it very interesting in kind of looking at that information compared to, where we are here in 2023 and with pandas 2.0 kind of coming out. One of the things that you mentioned in there was the popularity of the platform. And I don't think that's changed, though there are some other things you might mention as we talk today that are kind of coming up and that are also becoming popular in the sort of data science space. But would you say that the numbers have grown since then? You were talking about, pip install numbers like 5 million to like 8 million growth over, I think, like 3 or 4 years at that time. I'm not putting you on the spot to go look up what the numbers are, but in your experience, has it been growing?
Yeah, I have an idea. I didn't monitor so much, and I think all these numbers also are, it can be heuristics. It doesn't really because it's a bit difficult. I think the one that I trust the most also has a heuristic is the number of visits to our documentation. I think that that's more because the pip installs, I think they're affected by bots, for example. If you have like lots of CI jobs using pandas and that, I assume, I'm not sure if there is any way that people use to distinguish what's humans or what's users or that. But I would say if CI systems are much more popular now, I would assume that would change a lot. But if I remember the numbers correctly, I think at that time when I was checking a few years ago our documentation, I think we had something like 1 million unique visitors to our documentation per month. I think now it's around double than that. So I would say in absolute values, I think Pandas for sure has more users based on the numbers that I've got. I would say that in terms of the share, in terms of how much people are using Pandas on all the available DataFrame tools, I would say probably it's decreasing, and I think that's a good thing because for many years Pandas didn't have much competition, and I think Pandas is solving too many different problems, like the users are, I would say, extremely diverse. I think many people won't realize probably, but using pandas in a Jupyter notebook is very different than using pandas to build a pipeline like Python file in Git and running it nightly to say in Airflow and that. I think there are many things that change from the experience, from the speed that you need, from exactly what you're doing. And I think having more options, more different tools and being able to get more custom tools for different jobs, I think it's a very good thing. So I think it's decreasing, and I think it's a good thing that there are more options available.
One of the big things that you were talking about at the time, you were on the cusp of 1.0 coming out. At the time, I think you were discussing this idea of it being like a parallel branch of, I think it was like 0.26 or something like that. I can't remember the exact numbers, and that seemed to be I'm not positive of that, but since 2019, as 1.0 came out, and then as you guys started working on 2.0, you kind of did the same thing. And you were mentioning that Pandas is always kind of using this semantic versioning. And has that held the idea of keeping a parallel branch to, not have breaking changes as somebody gets introduced to the other version?
Yeah, I think we do a bit different than other projects, or at least that what people, I think, usually expects. We have a parallel branch, but the parallel branch that we use is only for the patch releases. So let's say that if we are now in 2.0 whatever, we will have for 2.0, we have a parallel branch that only gets bug fixes and important regressions on that. And everything else is in the main branch. So when we released 2, I remember reading someone, I don't know where they got the idea from. I think it was someone just assuming or guessing. But the idea was someone saying that Pandas 2 has been in the making for so many years. And I was not really, actually. Pandas 2 was basically considered Pandas 2 to say, since 1.5 was released. When we did release 1.5.0, then everything that was changed there from in main basically became Pandas 2. Everything in the 1.5.1, 1.5.2 was in a parallel branch, but it's not something like a 2.0 or 3.0 branch. We don't have a 3.0 branch now. Nothing is done for that. Everything that we're doing today is for 2.1. And I assume Pandas 3.0 would come after 2.3 or 2.4 and won't, the development, properly speaking, won't start until that point. I think it's there are a few things, in very few cases, people have a branch for a particular feature that we don't want to commit yet. But yeah, that's very, very small things. In general, there is no, let's say, secret development of pandas in parallel for 4 years. What you are getting, if you get main, basically, that's what we've been doing.
Okay. So one of the biggest things with Pandas 2.0 was this introduction of the Apache Arrow, and I want to make sure I get the terminology right, but basically the idea of this representation of the data in memory as sort of Apache Arrow objects or data, and this sort of change of, I don't know if the term is extension arrays. Is that what you call it? So maybe you can kind of clarify my ideas there. What do we call this thing as far as how the the data that you have in your data frame and it being representative memory and the change that's happening with 2.0?
Yeah, that's a very good question, and I think it's a bit confusing, and I don't think most people probably understand exactly in detail what we got. Pandas was built, and yeah, I think it's worth probably remembering people that Pandas is probably like 15-year-old technology now, and
Yeah.
I don't know exactly when it became like very popular, but it's been like so many years that Pandas has been pretty big, and being pretty big means even if we didn't reach 1.0 until somehow recently, like Pandas didn't want to break too much. So it's been kind of stable because we knew, and well, we knew people before I was involved in the project knew that yeah, like hedge funds was using Pandas in production. You cannot just come one day and say like, oh, I changed all the API because I think it was wrong.
Yeah.
Or I changed all the internals or something that was working, now it's broken. So yeah, like the change happened slowly and very carefully. And I think that's a good and bad thing. Of course, it has a penalty, a big penalty in innovation. Pandas is not going to be like the most innovative project. Right now it aims to be like probably the most stable or a very, very stable one. That being said, like Pandas being 15-year-old, Pandas was built as a wrapper on NumPy. For users who might not be familiar where this is coming from, like Python is probably like the least data-friendly language that we've got. Like, I don't know, maybe JavaScript is the same, but yeah, I'm not sure if that's obvious for everyone. So it's probably worth like expanding a bit on that. But yeah, using Python lists for representing the data of a data frame would work when you have data frames with hundreds of rows. But if you start to have rows with thousands, tens of thousands, hundreds of thousands, or millions, like that would be dangerous for in terms of speed. Like Python lists are not designed for representation of data and for computations at that level. So with that in mind, like the scientific community came up with NumPy. That was the marriage of two different projects like scientists were using. That was pretty nice. And that's basically like Python lists that make a different trade-off, that they allow only a single type. So you cannot mix in a Python list, you can mix like numbers with strings, with any kind of object. In NumPy, they make a different trade-off, and they say like, okay, you can only have one type, and that's like equivalent to a C array. And a C array, basically, the operations are super fast.
Yeah.
So that being said, like Pandas was built on top of NumPy. The thing is, like NumPy, like has been a scientific software designed for mostly floating point numbers. That's what scientists use the most. It also supports integers extremely well. It doesn't support many other types really well. Now I've heard that NumPy is implementing a string data type. Like it's like there is something that I think makes things a bit more confusing. That NumPy, what it does is it implements a Python object type, and a Python object can be literally anything.
Yeah.
It can be like a function, it can be a date, it can be like a string, it can be whatever. So if the data type cannot be represented as numbers, as the ones that NumPy supports well, it's been always supported in NumPy, but the performance is as bad as a Python list, what I was saying. So
yeah.
With that said, like Pandas has been just this wrapper, just creating this structure that pretends to be a bit of a dictionary of columns, where every column is of a single type. So that means that it's an NumPy array, and operations on them are fast. That's the general idea. For numbers, as I said, like NumPy supports them really well, and actually Arrow is not bringing too much new. Actually, the representation between NumPy array and Arrow array for integers or floating point numbers is the same. There might be differences in terms of the header or whatever, but the data is going to be exactly the same. So if you're only working with numbers, there is not much difference on what it's coming on all that. So the main difference comes because DataFrame support columns that can be dates, can be strings in particularly, and can be many other things. They can also be a list by itself. They can be a struct. They can be so many different things. Binary data. All these, the support with NumPy was not great. It worked in some cases. In some other cases, it was this fallback to that. So yeah, what we're bringing with Arrow, and it's not coming exactly as I say, like Pandas is being developed like like let's say version to version. There is no parallel development. So actually Arrow was introduced before. So what pandas did is like, okay, we were wrapping NumPy arrays, and at some point we see that there is much demand for different types, for different things that just NumPy arrays. So that's the concept that you were saying about extension arrays. And it's saying like, okay, I have a column that, okay, it's going to be backed by something, probably NumPy at the beginning, but it can be, I think the original one, if I'm not wrong, was using null values in integer fields. Or no, that was not the first. I don't remember exactly which was the first extension array, but no, I think it was the. Well, there were some. I'm not sure exactly because the concept of extension array, like, it has this meaning of like an array, like the column of a data frame that you can extend, but at the same time, this is the one that we use internally. So actually, we have like categorical, for example, it would be an extension array, but it was not implemented as a pandas extension array, as the class extension array to say. So yeah, that might be a bit confusing. But yeah, let's say that pandas identified that we had more and more demand for different types, that they were not just like a NumPy array. Like as I say, like the categorical, the time frame with a time zone, and the time frame, the date time with a time zone. That was another one. And then eventually we also saw that, for example, for strings, as I said, NumPy supports them, but with a penalty on performance because they are Python objects. So we wanted to implement them also. So everything became an extension array eventually. The ones that we already had became part of this interface, and also the new ones that have been developed. And that also allowed, because now we had this, like for several versions, I don't know exactly when was introduced, I think pandas 1.2 maybe, or around that time, I'm not exactly sure. But since we have this concept of extension array, it's like, okay, we now somehow easily, and it's surely not easy, but easily to say, we can start like using other ways to represent and say like, okay, even the numbers themselves, we can represent with Arrow. Pandas 2 introduced support for most of the types on the Arrow specification, including the numbers that they were backed by NumPy and that. But like, for example, the string one has been there for a while. I think it was in pandas 1.3, if I'm not wrong, that we started to have one. That it's not the one that comes by default. And in pandas 2 also, it doesn't come by default in Arrow. And I think many people got confused. I think probably the article you were mentioning that I wrote has a bit of responsibility on that. Because yeah, the idea was to excite people about Arrow, because I think there are many reasons why be excited about Arrow. But as I said, like pandas wants to be stable. The main goal is to be stable, not to be too innovative. So for now, pandas is still the same pandas as before, with very few changes. All the Arrow types are opt-in. Even the string one, that starts to be a pretty mature one because it's been there for a few years. Like if you want strings backed by Arrow and you want the speed of operations on strings on Arrow, you still need to specify that the type of that column is a string backed by Arrow and not the default. It's going to be on NumPy.
Okay. So you have to still kind of pay attention to, as you're defining this stuff, to say, I would like to use this extension on it. And so that's something you have to define, specializing the types inside there.
Yeah, from the user point of view, it's not the extension itself. That's like how we do it internally, to say, like that's our structure to say, I have a data type. From the users, what they deal is with data types. So what you say is like, okay, the data types, for example, when you're loading from a CSV, I think you have the parameter to say, okay, my data types are this. So there you need to say like, okay, load it into an Arrow data frame, or you just cast later, you have the as type, and you say, okay, this column as type. And then you can say like, okay, let's this be backed by Arrow or backed by whatever, or if you want one type or another.
So one of the things that you were mentioning back in the 2019 talk was something along the beginning lines of that NumPy, you already mentioned it, isn't great with null types. And one of the things that it would do with integers at the time was it would, if you had an array of 5 integers and then one of them was a null, it was auto turning it into floats because the nan value was a float value and they all needed to match. So it would just sort of cast all of the integers into floats, which is a different type of value potentially. Having worked with Python for a little bit, you can see common things that happen with floats that are a little odd. And so is that something that the extension was able to solve? Because I'm going to mix two things up here, but you also were showing this idea of a case where maybe it's something that's defined as true and false Booleans, and then suddenly there was one that was a null, and it didn't know what to do with having, what would be theoretically a 1-bit value, and then having a non-value in there. And so it was having to cast it all the way into an object back in the day, which was really kind of throwing everything off to have like nan with, true and false. So that I feel like maybe you were talking about this in the talk about this was maybe the beginning of an extension of saying, well, we could have a mask that's applied along with it that basically says value versus not value along with it. So it would have like, sort of two sets of bits, basically one bit having the true and false, and then another bit along the lines is like, these are values and then not values. Is that kind of where some of the extension stuff kind of began? And has that improved with Arrow?
Yeah, absolutely. Yeah, that's a very good question. I think it's one of the very pain points of pandas. Probably, I think it brings a lot of confusion. I think something that more experienced developers might know, but some other people using pandas notice we've been using as a representation for null or for missing value. We've been using the none, not a number. The not a number is a specific value of the floating point number. When I mean floating point, it's there is a standard of floating point representation, people who study information technology or similar thing might be aware, but there is a way that you say okay, I have the exponent, I have the base number, and then have all that. Floating point is a particular value of this representation. There is also a minus infinity and an infinity, and I'm not sure if there is any other special value. This gets hard coded into the CPU. If you are Intel, you are AMD, you are NVIDIA, when you design your circuits, and you say okay, the addition of two floating point numbers, basically you hard code in your CPU, in your chip, you hard code that this possible representation of NaN has certain results. So if you're summing one of them, the result is also a NaN usually. That's the general idea. So pandas, let's say, out of the possibilities at that time, that it was limited. It was just as I said, a wrapper around NumPy, and yeah, it's not and it was not an area all the DataFrame technology as mature as now. They say, okay, let's use that. And at least pandas was using mostly numbers because it's what NumPy was using, and floats support that concept of NaN. For strings was not a problem because strings were not supported. They were Python objects. So if you're a Python object, you can be whatever. You can be a Python none. So the only pain point to say was with integer numbers. So the easy fix to say at that time is okay, a float more or less is an integer can be represented as a float. I think personally I kind of disagree. A floating point is an approximation. So for example, if you ask me personally, I wouldn't, for example, allow comparisons among float numbers. For me, a floating 2.0 and a floating 0.0 shouldn't be able to be compared. It can be compared for inequality, saying this is bigger than this other one, but I would say you couldn't be able even to compare them directly because they are approximations. It should always be false, and I think it's better just to not allow comparisons. I think we should be able to compare only by inequalities.
Yeah, it's funny because that it always leads into that whole financial thing. People say, please do not do financial data with floats. It needs to be a decimal value or some other kind of value that's more strict than what a float's doing.
Yeah, if you say, that's a very good point, because then things are not going to match. You have the solution of the London Stock Exchange that is do it everything with cents, with pennies in England. So if you check a stock on the British market, everything is multiplied by 100, and then they don't have this problem. They have integers. Databases deal with this decimal type, and it is not a floating point. It's just let's say an integer that you know where it is going. So you have all this. So that's a solution that kind of work. Is okay, let's work with missing values. For strings, we use none because they are objects. They are not well supported anyway. For floating points, we have it solved. The only issue is with integers. So let's cast any integer column that has missing values. Let's cast it to float, and then we use the num. But none is not really a missing, it's a none, it's a concept of itself and that. So eventually, as the tool became more mature and that, pandas realized that, Arrow realized that, and it's kind of like the same thing because Arrow was co-founded by, or co-started by Wes McKinney, who was coming from creating pandas himself, so he knew about the pain points and the trade-off that he had to do. So in parallel to say like pandas started to develop and let's say that the best solution, and it's not like let's say like a perfect solution probably, but the best solution instead of having this sentinel of the floating points in others, because that would be very tricky. That would mean that, for example, if you have an integer represented by 8 bits, instead of going from 0 to 255, you will have to go to 254. And many people wouldn't probably even realize, but the ones that realize it would be very painful and very confusing having 8 bits and using one for this and some operations that don't implement that. The missing values would be just the 255. That would be, I think, even worse, like reserving one value in every data type for that as the float is doing. For float, since everything is an approximation, just having one of the millions of possible values as that is not a big deal, and this was made anyway by chip manufacturers, so that's not something that we control ourselves. So the alternative, the part that the solution that has been implemented is saying like, okay, we can not represent like with 8 bits like an integer and the missing values, so let's use the 8 bits for the integer as it has to be, and then let's have in parallel an array that is transparent to the users, that in the case of Arrow it's called validity, and it's just like bits, and for every position in the array there is a bit that says if that bit is valid or not. If the bit is not valid, it means that it's no. And when you do operations, then you do operations on both arrays. If you want to say how many null values there are in this column, you don't even need to go to the array itself. You just sum all the ones in the validity column, and that will give. So for the user, it's transparent. The users don't even know. The cost in terms of memory is not that huge because they are bits, and the actual representation is just bits. So I think it's a pretty decent solution. The thing is, like, the timing was a bit bad. I think, like, in pandas, I don't know exactly if that was intentional or not. We knew a bit what was coming in Arrow, but I don't know. It was at that time more a promise than something as it today, a reality. Pandas decided to implement that. So implement that, not having that marks and that. And pandas does implement its own system for nulls.
Okay.
I don't really like the terminology. I think it's a bit confusing, but if you want to specify that, instead of saying int 8 and int being lowercase, if you capitalize the I, that would mean that it supports missing values with these extra columns.
Oh.
It's something that I would personally, I don't know, it seems like it wanted to keep the type short, whatever. I would personally be super happy calling nullable int and making the users write on that. I'm also an advocate for not aliasing pandas as PD. I don't think there is any reason for creating an alias for pandas as PD. It's not saving that much. And in the verbosity,
that's a Xena Python thing there, right? Explicit.
Yeah, it's. I mean, it became so common, but now all the projects started copying the same thing. I think for NumPy, that was the first one to do it. I think it was probably not the best decision, because if they really wanted to do that, they just could rename the module to NP, and then you just import NP, and you have a pretty short one. But yeah, for NumPy, everything is in the NumPy namespace. So every function, everything you do, it's gonna be np.something or numpy.something. I don't alias NumPy for the record. I don't use it so much, but I'm pretty happy just repeating NumPy. I don't think it makes a big difference. But yeah, for pandas, in the case of pandas in general, everything is a method of DataFrame, not of pandas itself. So most pandas code will have pandas, the word pandas, only once.
Yeah.
So having alias as PD, it's kind of like a funny thing, but I don't know. I'm not a big fan of it. So since I'm not a big fan of that, I'm not a big fan of also calling the nullable types like in with capital letter. I think that's a bit more confusing. I think it would be better to be more explicit, but well, this is what it is.
Yeah.
The interesting thing is, like, this has been there in pandas for a few years, but yeah, Like now, everything in pandas, including the numbers, is also supported by Arrow. The support is not as great as with NumPy. As I say, it's not as stable, and also let's say that every single algorithm we mostly need to replicate it for NumPy and for Arrow because the data structure is the same. Not so much for numbers, but things need to be adjusted. We need to make sure that things don't get cached greatly, and there are a few things that needs to be done. So there is an ongoing work, and it's not yet there. But in the future, I would say that I'm not talking for the whole core team, but I guess that everybody more or less envisions that Arrow is going to be the only one. Arrow is giving that for free to us. Now Arrow exists. When we implemented it, it didn't exist, so it probably didn't. I mean, it was probably a good thing to bring users this feature in advance. Now I think like these label types with pandas is redundant, and with time, when the Arrow types are stable enough, I think users can probably forget about them because it's already implemented in Arrow, and I think that's a better approach.
Yeah, probably the big advantage that you were talking about in the article, the pandas 2.0 Arrow revolution, was kind of two things. One would be speed, which kind of translates to some of the stuff that you were talking about. If you're working with just pure numbers, pandas has been behaving pretty well for you kind of across the board, and you might not have noticed it. But I think as things have moved on in data science, and there's so many fields where there's just lots of different types of data, especially large language models, lots of strings and text and dates that you were mentioning, all these other types of data types. There's this sort of need for ways of representing data other than just integers and floats. And so I think that it's great that we're moving into this revolution of being able to work with these other types of data. And so the biggest thing that you were mentioning kind of briefly there is about strings. One of the reasons that strings were a slow type to work with in there is because they were cast as an object. Even an empty string, like just a pair of quotation marks, would take up, I don't know, was it like 54 bytes or something like that? It's a pretty large amount because it is an object. It's a Python object, and it has all these things that it can do in the representation. And so NumPy, when it was representing it inside of pandas, it was doing it as pointers to Python objects. And so it's sort of this large thing in memory, and it ended up being partly why things were slow. So with it being a string in Arrow, it's a lot more optimized because it's more at that sort of C level. It's the way that it's being represented. It's less of an object. It's more of a true, like, just string object. Am I getting that right? Is that one of the big things that's going to help with the speed?
Yeah, absolutely. Yeah, that's totally correct. Yeah, one of the things also is that the design of the Arrow format, besides, like, as you say, like the Python format is not designed like the trade-off there is like every Python object is kind of like independent, and the list, the Python list, being able to have different types comes at the cost that you need to know. Every type needs to know itself what it is. To say every value, needs to know what type it is, and you need to store this information. And every value have like its own reference count to know like when this memory needs to be allocated and all that. So yeah, that comes at a cost, but it comes probably at a bigger cost than the memory footprint itself. Like knowing that the amount of memory is that the CPUs, modern CPUs, are extremely fast, but memory is not as much. Like the memory speed didn't grow as much as the CPUs. And we have this problem about like CPU starvation. That is like the CPU is able to compute super fast, but data is not coming from memory enough. And the solution for that has been for many years now, it's been the CPU cache. And the CPU cache is designed in a way, both at the architecture, at the hardware level, and both at the operating system level, in a way that it's kind of predicting. It needs to, like, the general idea is like the CPU, the CPU, the operating system, or the hardware itself needs to guess what's the next thing you're going to need. That's why you can bring to the cache in advance, have big chunks of memory going to the cache, and then whenever you need to do the operation, you have everything in the cache. And if you're working at the C level, like in general, the CPUs are assuming that, and the operating system is assuming that. And if you're working with arrays, it's going to predict that the next element in the array, in the operation, like pipeline to say, it's going to be the next one in memory. And for C arrays, that it's true. But for Python objects, it's not. Because you're going to bring to the cache the reference counter, the type, and all the other information that you have in the PyObject struct. And that's going to have a huge penalty, much more than the operation of the CPU itself. It's going to have a huge penalty in terms of all the cache that you're wasting. And this is usually the main bottleneck. So yeah, the nice thing is that Arrow is designed like with this in mind. Like Arrow is designed, for example, if you think something as Postgres, and I really like Postgres, I think it's one of the best databases that we have for many years. But in terms of analytics, Postgres is storing every row like next to each other. And that can be nice for certain operations. If you want to bring the 10 first like rows of whatever, that's pretty cool. But if you want to do an operation on a column, that's going to be kind of slow, because you need to literally look from different parts. Every value it's gonna be in a different part of the memory. So you need to pick one here, one here, one here.
Uh-huh.
You cannot make any use of the cache, like, because you cannot bring a chunk of memory to the cache and then use all that cache of memory, because it will contain all the other values in that row. So Apache Arrow is a columnar format. It's designed with this in mind. It's designed on the kind of operations that users are more likely to do in terms of columns and that. Thinking about the cache, it's also designed in terms of SIMD, single instruction, multiple data, that it's some sort of parallelism that modern CPUs usually implement. So it's also designed in terms of making SIMD like work well. So yeah, Apache Arrow is a format. I say for numbers, like if you are considering an array of integers in NumPy or in Arrow, it's the same exact thing. It's just one after the other. But if you start to have the null values, a possible representation, for example, could be like having an integer, the 8 bits or 64 bits, whatever is your precision there, and next to it having like the bit to say, or maybe I don't know how many bits you want to store, the validity, the null values. You could keep like having them, but that would have this penalty, because in general, as I said, like when you're doing an operation, if you want to sum values, you might want to sum them, or if you want to know how many null values you have there, you might only apply on the validity. So yeah, that representation of having two separate arrays and being able to process them separately can help in some cases. I mean, of course, there is always a trade-off, and of course, like in some cases, you might want to iterate over both at the same time, and then you will come with a penalty. But in general, Arrow is designed with this in mind. It was designed by people working in these technologies, coming from pandas as well, and from others. I think people from Spark or from these technologies also were involved, and from R. So I think it's very nice that the different people was having their ideas, and they managed to find a format that I don't think it's perfect. It of course has trade-off, and there are things. For example, if you have very sparse data, I think Arrow is not great because of what I was saying about this validity. Because imagine that you have like an array with, I don't know, 10 million values, but 99% of them are null. Like in the Arrow representation will still store all them. So of course, like it will be just, let's say, garbage that you have there. It will be, but it's just still allocating all this memory. I don't think that's probably very realistic. That's what they make this trade-off, and it probably makes sense in most of the cases. But of course, like it's not that Arrow is like the best that we can have, and I assume like in the future maybe new use cases come and maybe new data types are needed with different representations. I know that the few technologies, particularly DuckDB, I think it uses mostly Arrow format, but I think they have few differences like in there. I think, like, for example, if you have null columns, I've heard, like, I'm not sure if the difference is like a column where everything is null. I think, like, yeah, MTP have like just a number for that. Well, I think like Arrow is probably like allocating memory. I'm not sure if for the whole array, but at least for the validity. So yeah, I think there are differences, and of course there are always trade-offs. So it might not be like, it's not saying that it's perfect, but it's much better. I think it's a very well designed, and I think it's like serving really well for the current needs. So yeah, it's gonna make a huge favor, and also it's pretty, let's say, complex, or more than complex, I would say rich in terms of the data representation, because strings is pretty obvious and you can get into dates and that. But for example, a very interesting one that is getting a bit more attention lately is embeddings. like with all these generative AI, large language models, and artificial in general, intelligence in general. So imagine a data frame where you have some sort of text, like, I don't know, sentences. I don't know, imagine like, I used to work for a dating app, so I'm going to make an example based on that. You have information
Sure.
about the user. It's not a real case that I had, but yeah, if you have information about the user, you have their name, you have their age, you have whatever, and you have their profile description, where you say, yeah, I like cats, I like yoga, I like whatever you want to say in a dating profile.
Right.
And then imagine that you want to represent that with embeddings. So you could have with Arrow, not with NumPy, not with other representations, but with Arrow, you could have like the string representation with the sentence of your profile. And then if you're going to represent that with embeddings to try to find a semantic meaning to your whole profile description and that, you could have a column where every value in that column are embeddings. So it's just like another array with, I don't know how many like embeddings are usually used, but I think it's something like maybe 100 dimensions or 1000 dimensions. So you could have that in columns. And imagine that you also want to have in the same data frame, you want to have the picture, the profile picture in JPEG or in PNG and wherever. You could have with a binary column, you could have the information also. So you could literally have like almost all your data, and it makes sense because at the end, if you have like a database of users from a dating app or whatever example you want, you still have columns and you have rows as individuals and columns as concepts. So the fact that these concepts are more complex and require, like, as I said, like this embedding is fixed length lists or maybe a struct with values. Another example that comes to my mind is like the latitude and longitude, for example. If you want to have like geographical data, imagine from the same user that I was using as an example, want to say the last location, then yeah, I can have a column for the latitude, a column from the longitude, but I also can have a column that it's like the coordinates, and then I can have two values because Arrow support the strokes, it support lists, it support more nested complex structures.
This week, I want to shine a spotlight on another Real Python video course. It's about a topic we touch on this week, working with pandas data frames. The course is based on a Real Python tutorial by Mirko Stojilovic. And in the course, Cesar Aguilar takes you through what a pandas data frame is and how to create one, how to import a CSV file directly into a data frame, how to access, modify, add, sort, filter, and delete data, how to handle missing values, and work with time series data, including slicing data frames using date-time indices, and how to quickly visualize data. Knowing how to work with pandas data frames is a good investment of your time and an important starting point for anyone interested in data science. Real Python video courses are broken into easily consumable sections, and where needed, include code examples for the techniques shown. All lessons have a transcript, including closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the enhanced search tool on realpython.com. I feel like that kind of leads us into this thing that you were talking about, this interoperability. And I'm kind of wondering, like, on the roadmap, it sounds like this is something that is still, we're headed toward it. The idea that once information is in this arrow format, it's in this sort of data format backend in memory, that potentially other tools, like you've mentioned GPUs a couple times here, like, NVIDIA tool or some other kind of platform, or maybe even going to another tool like Polars or something like that, could have access to that data without having to convert it. The idea of you're not going to spend CPU cycles of deserialization or reserialization or whatever you want to call it, kind of going in and out of memory. It sounded like that was like a pretty huge goal for Wes McKinney's ideas with the group's called Voltron Data now, I think, with bringing in all these other players to say, hey, let's agree so that we can kind of have all this data in memory. Where are we at with that? Is that happening? Is that working as far as with the Arrow data now that it's this data format backend? How are we on the timeline as far as that working?
Yeah, very good question. I would say from the pandas point of view, the first thing that we need is that users are explicitly using Arrow. If users basically install pandas and use with the defaults, they are not benefiting from any of this. So from the pandas point of view, we are not so close. And I'm not even sure if for most users it makes sense to immediately move to all Arrow types, because there are some operations that are slower. As I said, like implementing everything in Arrow is kind of like re-implementing the whole pandas to say. It's not literally the whole pandas, but it's like just to give a bit of an idea, it's a huge amount of work. And it's been a lot of work on that space, but a lot more work still needs to be done. And I think I've heard, I don't know if it's fixed now, I didn't follow that part exactly, but group by, for example, I think if your types are Arrow, I think group by became much, much slower compared to using the NumPy. So yeah, it might not be for all the users and for all the cases. In some cases, it surely makes sense. And yeah, I wanted to write that blog post to make people aware and to make people able to start experimenting with it. But yeah, it will come if you really need the stability, and if you cannot spend the time, it might not be yet the time for moving fully to Arrow. It's not saying like, oh yeah, we don't give it by default, but you should totally go there. I mean, we don't give it by default for the good reason, also because we are very conservative in that sense. But yeah, but
Right.
there is a cost in terms of risk and also in terms of operations that are not there. But yeah, like the work is going, it's working fast, and yeah, it will be there eventually. That being said that Pandas is not giving you any of the Arrow benefits by default. Like the Arrow specification is standard, the Arrow specification is already implemented by lots of projects. So I think we are already there mostly. There were a few issues I was trying, in particular the integration between pandas and polars. Like when
Okay.
just before releasing pandas 2, I was checking if these promises. Also, when I was writing that article, I was checking if these promises are okay, like being able to change from one to the other. And yes, since both of them are in Python, well, polars is much more than in Python. Polars is a Rust library that has like I've heard even that there is a programming language. I don't know the name of it. That there is a programming language that basically implements data frames, and it's actually polars internally. So yeah, like polars is much more. You can use it from JavaScript. I think they have bindings for different languages. But yeah, like the main one, I think it's Python. So if from the user point of view, or when using your Python and you're building a pipeline, and I don't know how many of users are familiar with this method chaining, but the idea is that instead of keep assigning to a variable usually called df and saying like, okay, the frame is this, and I assign to df, and I do an operation on df, and I assign to df again, and that is what we usually would do in a Jupyter notebook, and I think it makes sense there. But if you're writing proper code, what I would recommend is using this method chaining, that it just like, since the return of most operations on a data frame is a new data frame, just basically run everything like by brackets, by parentheses, and then you just write like one line after the other, you just by the period, whatever. So you do read CSV, and in the next line maybe you want to something, so you literally do like period sum, and you keep doing everything that you need to do in that syntax. So particularly if you're using that syntax of method chaining,
Yeah.
I think like being able to say like, I don't know, imagine an example. You're reading data from SAS, that it's I think quite a legacy technology now, but some users still have these formats. Like polars don't implement SAS, and I don't think polars should spend the time on implementing the SAS reader, but pandas does. So you can have like these pandas read SAS, you use this functionality from pandas, and immediately after you could call in this pipe that I was in this method chaining, in this pipeline that I was mentioning, you can do like literally two polars, and then from there you do all the operations in polars if they are faster, and eventually maybe you need something that is implemented in pandas or for whatever reason, and from polars you can do that to pandas again, and you literally can have like all your your pipeline like step by step, and you keep changing from polars to pandas. And the nice thing is, like as you were saying, this is there is no serialization here. Like polars is going to access the same data if it's in Arrow. Like if it's in NumPy, that's a different story. For integers, actually, it won't be copying memory in most cases. As I said, it's the same representation, so things are usually smart enough to not make the copy. But yeah, if you have strings or any other type, like you still would be able to make operations on the same exact data from one technology into the other, and you won't even realize, and you don't need to pay the cost in serialization. And serialization is expensive, but even more expensive than serialization. And just to be clear, serialization here means changing from one form to another. Like even if it's the same data, it's the same data frame and from the user look exactly the same. If internally the bits, like the zeros and ones that you're storing in memory, are not formatted in the same exact way, like to work with the two different technologies, if pandas and polars are not using the same internal representation, exact internal representation, they have to do this serialization that means change from one format to the other. And this, of course, requires CPU because you need to transform the data bit. But I think worse than the CPU, as I said, is the memory. I think memory is extremely expensive. As I was saying, like memory couldn't evolve in terms of getting faster as fast as CPUs. So at the current time, like nowadays it's like super costly it's still extremely fast, probably microseconds or whatever, or milliseconds in some cases, but compared to the rest of the operations, and depending on, of course, the volume of the data, if it's terabytes, it's surely not microseconds. Like it can be like a huge important part of the time that it takes to execute your pipeline. It would be copying this memory. So the fact that this is memory copy free, that you don't need to really copy this memory, I think that's extremely huge.
Yeah. So I was kind of mentioning before that the article you had written, the Pandas 2.0 and Arrow Revolution, had a part one in parentheses after it, and was kind of wondering when part two was coming, and kind of maybe what it would cover, and if this would be along some of the lines that would be in there.
Yeah, that's a very good question, because it's been a while since that article. I don't know how many months. But I'm actually working on that the last days, and yeah, there are two things that I wanted to cover. One of them I'm probably not covered that much in that article, because I'm not sure if it's happening. So one of them was the one that I think I mentioned, was the how being in Arrow, like whenever pandas when users decide to use Arrow, when pandas is ready for being like Arrow by default. Like one of them would be that to be able to write directly for Arrow, instead of, if you were writing an operation, imagine, like I have a couple of examples I've been working on. And one would be images, for example. I mentioned before that we could have like a column of a data frame could be an image in its binary format. And then if you have that, you could implement as operations of a data frame. You could implement things like resize, change from JPEG to PNG, make the image black and white or grayscale or whatever, like that, or crop the image, resize, whatever. Like there are so many operations that you could do. I don't think pandas, or not even polars, that it's much newer, any other technology is ready to have many more operations. Like you mentioned before, that serious object has already 200 methods. I think that's way too much. I think that's already too big to have it in the core of pandas. I think pandas should be like much more modular. That's my view. I don't think it's happening. I'm not suggesting it's happening at all, but if it was my decision, I would say that half of the things that pandas bring, it would be extensions. It would be plugins. If you want statistical things, like you basically insert pandas stats and you get all that. If you are going to work in date times, and there's a lot in terms of date times in pandas, I will have that in a separate project, and that all the I/O. I was mentioning about the read SAS. If you want to have read SAS, you would have to get an extension. This is not the way that pandas was designed, and I don't think there is much support to make pandas be this way. I would say, unfortunately, because I think that would be huge for pandas. I think it's the best that it could do, but I think we're very far from having consensus on that. The interesting part is that if that was going to happen, I think that Arrow makes a huge difference. As I was mentioning, this possible column that represents an image with all these operations that can be implemented. That could be implemented in a third party. And the nicer part is that it's not necessarily, it wouldn't be necessarily a pandas plugin. It could be a DataFrame plugin in general. And Polars could use exactly the same, because Polars internally is also using Arrow, the same exact data as pandas. So I can implement all these operations for a structure, for a column that would be Arrow, in this case a binary column on Arrow. I implement all these operations, and of course, like the final wrapping would be, every project probably would have their let's say, their syntactic show, or the way that they express that and the way that the users are able to call all these functions. But the extension itself would be independent of the project. And I think that would be huge. I mean, that would mean that literally every single algorithm somehow would be able to live independently. And that means that if Polars is much faster, I think Polars is much faster also for different reasons that I'm making things a bit simpler here. But yeah, if Polars has an operation, like, I don't know, string operations in Polars are faster than the ones in Pandas, why not actually have a third-party module that is like Arrow strings that implement all this? And then Pandas can use it, Polars can use it, and everybody can use it in the community. And I think Polars is great. I think Pandas is great and serve the users very well. But I think new DataFrame technologies will come. And I think the cost of starting a new technology, DataFrame technology today, is huge, because you need to reinvent everything. But if you had all these things, you would be able to implement a DataFrame technology extremely fast. So I think that would be a huge advantage. The same for the I/O. I think implementing all the I/O as third-party module, we're saying that would be huge. Saying like, okay, I have a SAS format and I have this converter from SAS to an Arrow in memory data. Like, okay, now Polars can use it, Pandas can use it, and I'm mentioning Pandas and Polars, but there are more technologies on that. Some of them are based on Pandas mostly. I'm not sure if they will also be based in Polars eventually. But yeah, even things like DuckDB, that they're not so close to Python, even if they have their Python interface. I think all these technologies would benefit from having an ecosystem of those things. And there is no value added, I would say, in reinventing the wheel. So I think Arrow allows that. I'm not sure if the fact that allows that, it means that it will happen. I think in some cases it can happen. I'm personally working on some prototypes on extensions, and that would be this part 2 of that. For the I/O, I made a proposal to Pandas to kind of have the I/O of Pandas with an interface, having an API on how Pandas interact with all the I/O, and keeping some in the core, and initially keeping all the ones that we have in the core, with the idea of moving the less popular ones to third-party projects in the futures, and with the idea that we have so many new formats coming up all the time, and all these formats would be able to also implement in this API, and then it could be reused also by other projects. But unfortunately, I didn't get any support from other people in the Pandas team. I personally don't know exactly why, but yeah, people didn't seem so excited about it, and I didn't. Yeah, like there was some discussion online, people had some ideas, but yeah, like it was very far from reaching an agreement. So yeah, the proposal was finally rejected, and I don't think there is much going on that. That doesn't mean that it cannot come from outside. I think coming from Pandas, it would be better, because I think Pandas is still the leader in terms of data frames. And I think if Pandas implements this, it would be a pretty strong signal for the rest of the community in terms of adoption and all that. So like, okay, all Pandas I/O now has a protocol and an API that we can use and we can communicate. That doesn't mean that you cannot do that in Arrow, and Arrow have like an interface. And Arrow itself is the interface. The thing is, like, you still need to wrap it somehow in the Python side, in the Python world. But so yeah, it might still happen, but of course this might or might not happen. And while we're in the open source world, there is some funding in Pandas, but it's limited in terms of what you can do with that, and of course in the amount of funds. And actually, I think it's getting worse recently. So I think Pandas might have a funding problem in the midterm. So we'll see. I don't know if it's happening or not, but yeah, particularly if there was funding for this, I think it would be extremely good for the ecosystem. And the last one would be the plotting. I did some work in the past on that. yeah, it didn't get into the level of having like independent like plotting libraries depending on the data frame that we are using. But yeah, that would be also pretty nice. And I think there is some work in that direction, and it might also happen. But yeah, I think like having data frames that pretty much don't have like the data representation is memory or the file. A lot of the work also is going to move into out-of-core algorithms. So instead of Arrow, it's great when you have your data in memory. But I think being able to do the operations before loading the data into memory when you're reading the file in this, that's going to be huge. Polar is already doing a lot of work in that space in the streaming mode, and I think that DB is also doing a lot in that space. Yeah, for pandas doesn't make that much sense because we are not lazy, so operations are executed when you tell them to be executed. So if you're saying read CSV, the CSV is going to go into memory directly. But yeah, for other libraries that are lazy, it makes a lot of sense that they move into that. But yeah, for everything that is Arrow, I think like Arrow should be like until there is something better, Arrow should be like the memory representation. I think the all the operations should be standard, should be generic, shouldn't be pandas operations or polars operations or task operations or whatever operations. I think they should be standard. And Arrow is doing some work on that. They have what they call the kernels, that it's operations on Arrow structure. So there is some work on that, but it's not like, let's say, an ecosystem that you can plug and like any operation into any library. We're a bit far from that. And yeah, I think having the I/O, the plotting, all that, and just like getting data frames like very, very small, I think that would be big. So it would allow the community and the technology to evolve much, much faster. That's my view.
Yeah, sounds like you've been thinking about this for quite a while, because a lot of those ideas are, included in your talk in 2019. This idea of decoupling and keeping things, modular in the way you're talking about, which I agree with what you're saying. It makes a lot of sense, but you have a lot of different customers, a lot of different people to please there. And so that makes sense that there might be pushback. And I think that kind of maybe brings me to this. You've had this Python DataFrame Summit. There was one, I think again, it was in 2019, but you have one coming up in 2023. And I think this episode should be able to come out before that. Can you tell us a little bit about what the Python DataFrame Summit is and like who's attending and what's going on with that?
Yeah, it's a bit of an, let's say, I'm not sure how to say that, internal event. Like it's like invitation only. It's for maintainers of these tools. Yeah, there's no idea. We had few discussions on that. I think there are lots of synergies. Yeah, well, I think it's related to what we're just discussing about modularity. I think there are so many synergies that can be found in these projects, and I discovered that people, when they start these projects, they have these ideas of, okay, I'm doing a pandas alternative, and in many cases you see some of these pandas alternatives that are branded like, oh, change one line of code and make pandas 100 times faster and all that. And yeah, it seems like, I don't know, in a way it might seem a bit adversarial. I do understand that for some people in the projects might be adversarial, actually, might take like, oh, this is my project and this is my project, as if it was a football team or a soccer team in the US or basket or whatever you're a fan of. Yeah, so in some cases, I assume, like, because in Pandas now it's 25 core developers, so I assume you have all the possible mindsets in there. But in general, I've been in the open source community since it was called Free Software Community. So it's been a while. I think the enemy has been any other free software project. I think the enemy has always been like a proprietary projects or our own challenges, right, in terms of making the tools or the challenges that we're trying to address, the inequality that I think open source is extremely good at addressing, like being able to have the same software no matter if you are the richest hedge fund in Wall Street or if you're a teenager creating your startup in Africa. Like, if your software is open source, you will be able to install Linux, you will be able to use pandas, and I think that's the main thing, and I think that's the actual battle that we're fighting here. I don't believe in fights win-win projects, even if some people can be a bit more passionate about their own projects. I've been doing some small contributions to Polars. There are some other pandas developers I know that also been contributing, so I think that's great. And I think, like, regardless of what we are contributing to, I think it's very good for the users. And as I said, I think serving our users should be the main goal here. Finding synergies in terms of pandas communicating well with plotting libraries or machine learning libraries like scikit-learn or many others, or communicating well and interacting well with others. Like pandas is being used by Dask internally, by Modin internally. Like in Polars is not using it, but as I said, there are use cases for moving from one library to the other. I think there are lots of opportunities, lots of experiences to share. I think we're a big family. That's how I feel. So we decided the Pandas team is meeting. We're meeting in Switzerland, just next to EuroSci-Pi. For people who want to also attend the conference, so we'll be meeting for discussing the pandas things, like our roadmap and different things. I think it's good to be together for a few things from time to time. And the team has been changing a lot, so it will be good to meet in person a few of the people that I never had the pleasure to meet. And since we had this opportunity, many of the pandas for developers will be there. It's also EuroSci-Pi. We decided to make it more open and invite other people from other projects. It's been quite successful, I would say. We'll have people, I think, from mostly all the projects that I'm aware of in this space. We then wanted to make it bigger. I think it's probably already too big. We're around 20 people. I think it's good to have all these people. I think it's also good to have a small group to make it very interactive and have the opportunity to have proper discussions, not just a speaker and lots of people listening. I think it's nicer to be able to have discussions among all of us. So we'll have people from IBIS, we'll have people from Dask, we'll have people from Polars, we'll have people, I don't remember every single library. We'll have people from Spark too. I think the person who is most involved in Spark these days. So I'm really excited about that. I think we'll be just 2 days sharing experiences, meeting in person. And I'm not sure if in 2 days we'll be able to address too much, but I think at least making the connections, knowing each other, knowing the mindset, everybody will have the opportunity to speak, what are the challenges in their projects, what is their wish list in their projects from the rest of the community, see what are the areas. And I assume most of the work will probably be offline after that. But I expect lots of things. We also invited corporate users. I think having the point of view of users is pretty important, having the maintainers of all these tools. And of course, as maintainers, we have very, let's say, we're very knowledgeable about the tools that we're using. But for me personally, since I became a pandas core developer and I get more involved in the development of the project itself, I get a bit more disconnected from pandas from the user point of view. It changes depending on the period. At some point of time, I work in pandas a lot as a user. In some others, I'm totally disconnected of what's going on in what's pandas for users. I get a bit disconnected from that. So we did that, and we invited corporate users. We still can have a few more, and the only thing we invited so far the ones that make financial contributions to the projects, which I think it's fair. I think it also brings adds a lot of value to the users, the fact that they can spend 2 days with the developers, know everything internally, know the people, have the networking, and know the people who are developing the tools, know the needs, know the roadmaps, what's in the plan. Most of the things would be somehow public. We are going to publish probably a write-up or something like that if someone has the time. But as I said, most of the projects have funding problems or would benefit highly from higher funding. So having these corporate users who are happy to support the projects, and also having in exchange this direct access to the maintainers and all the information that will be discussed, it's part of it. I think it's a win-win for both parts. So I'm very excited. I think we've got super interesting people attending, and I think it will be an extremely productive weekend.
Yeah, cool. So, Mark, I have these questions that I like to ask of everybody who comes on the show. And the first one is, what are you excited about that's happening in the world of Python?
Yeah, actually, I've been following things for the last months or probably few years. I personally felt a bit disconnected from the Python world itself in terms of the Python core.
Yeah.
I keep seeing a lot of the type annotations. I keep seeing like many of the things that are being developed in terms of like the making Python faster and that. I don't think in the data space we benefit much from those, or well, maybe it's also very opinionated in terms of my experience. I'm not so much of a huge fan of annotation type annotations in Python, to be honest.
Sure.
I mean, I think they add value in some cases, but I think like if I need to deal with type annotation, I probably prefer to deal with other languages. So yeah, I would say like I'm not so much excited about that. I think Polars is the project that excited me the most, and I think Rust is exciting me much more than Python. I think it's a bit complex language for some things, but I think it brings a bit the best of both worlds. I think it's enjoyable to deal with as with Python when you start to be good at it, and I think you'll get the speed gain. So that's really what it's been exciting me lately.
Yeah. There's a lot of stuff that's sort of interoperability between Python and Rust and sort of the Rustification of Python things. So it's a neat intersection right now.
Yeah, absolutely. Yeah, I think they interact extremely well. I think there is this Pio 3 that it's extremely good at interacting. And there are even other ways, like you can interact with Rust pretty easily with just using C types. And yeah, I think it's extremely good. I think, I don't know, for me it felt like in the last years that Python, I mean, I'm not talking here about the most of Python users. I think for Python users, Python has been doing a great job. And I mean, for me, for many of my use cases, Python is doing a great job. But on all the work that I do in terms of data and dealing with large amounts of data, and that Python became a bit hacky because we always try to push things into the Python world. Like Python is an example. I think Python is brilliant, like being able to transpile code from Python to C. Like I think it's brilliant, but it's a transpiler. And I think a transpiler by definition is a hack. I mean, you are like, if you want C code, probably it would be better to implement it in C. Of course, you don't want to implement it in C because it's challenging to program in C when you're used to Python or when you can program in Python. But that's why I'm saying that I think Rust brings the best of both worlds for the kind of work that I'm doing, and that it's like something that excites me, and it's how I like to spend a lot of my free time.
I guess that might be related to the next question then. What's something that you want to learn next? It doesn't have to be programming, but it can be.
If it doesn't have to be programming, probably I would say free diving.
Okay, cool.
I've been doing some free diving as an amateur, like for some years, and I want to get the certification on free diving. That's probably the next thing. But yeah, other than that, yeah, I think getting better at Rust is something I've been learning for the last months or maybe a couple of years. But yeah, getting better at Rust is probably the main thing that I want to learn in the technology space.
Yeah, are you having a chance to do some of the free diving stuff that you were talking about? You're like in Thailand right now, right?
I'm in Thailand right now. Yeah, I'm planning to do the certification if the weather allows, because the sea conditions are pretty bad these days. But yeah, if the weather allows, I think I'll probably be doing in 1 week's time, like the free diving certification. Yeah.
Oh, good luck with that. So how can people follow the work that you do online?
I've been using recently Twitter more. I have my blog, but yeah, I think the way that people usually follow what I'm doing is Twitter and also LinkedIn.
Okay.
In both platforms, my username is Data Pythonista.
Okay.
And yeah, everything that I do, like if I post something on my blog or anywhere, I would be sharing. Probably usually in both. Twitter, I like it a bit better because I think the conversations, like the how we implement threads and the conversation and the interaction with other people and getting feedback, I think it's the nicer. I tried Mastodon for a while, but I think that part is totally missing. I like the concept more. It's open source, it's distributed. I really like that, but the experience, I think it's very poor. I don't feel like interacting with other people. So I have an account there, but I rarely enter now. So yeah, I think Twitter is the best one because it allows a lot of like the discussions and all the feedback in a much nicer way. So yeah, but yeah, Data Pythonista in my website. I have a website, datapythonista.me, and there I also publish the videos of the most relevant talks or articles that I have, and also I have links to everything. I'm also Data Pythonista on Telegram, but yeah, there I publish some updates too. But I publish mostly memes, technology related memes in general, which I guess some users might also enjoy.
Okay, cool. Well, Marc, thanks so much for coming on the show. It's been really fantastic to talk to you.
Yeah, thanks a lot for inviting me. It's been a pleasure to talk. Really enjoyed it.
I want to thank Marc Garcia for coming on the show this week. And I want to thank you for listening to the Real Python podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and look forward to talking to you soon.